We're gonna see our first video of the day. It's nice to be able to see a video format, which is new to our virtual forum, and I hope you guys all enjoy the show from Amalgamated Vision and the Q&A to follow.
Hello. Every day we hear about the coming digital data revolution that will change the way we live. Extended reality and spatial computing will enhance our lives by making information more available and easier to understand. 7 years ago, Google Glass was released. Since then, tech companies have spent billions of dollars in the development of head-mounted display. Today, anyone can buy these products. So let me ask you, how many viewers at a NASA technology conference are watching this presentation wearing head-mounted display? I would be surprised if anyone is wearing smart glasses. So, why is this happening? When it comes right down to it, the single most important factor holding back widespread acceptance is the eyewear itself. Headsets are bulky and ugly. My 21-year-old daughters would not be caught dead wearing one. The resolution is poor, and despite what you've seen in the media, digital data in front of your eyes can be distracting and annoying. My name is Adam Davis. I am a neuroradiologist and the founder of Amalgamated Vision. We are an optical design company dedicated to creating portable personal head-mounted display, and I believe we have found a better solution. 20 years ago, I authored a paper describing the use of 3D stereoscopic imaging to guide medical therapy. It required low-profile, high-resolution display that would allow physicians to work with their hands and interact with their environment as easily and naturally as if they wore no headset at all. Virtual retinal display was identified as the best technology to satisfy these requirements. Using laser MEMS technology, the image is painted directly onto the retina of the eye. There is no display screen. Over the past decade, Amalgamated Vision created an optical engine that provides high resolution, brilliant luminescence, deep color saturation, and a wide field of view. Our compact size enables a look-down form factor that does not obscure the user's normal vision. It is ultra near to eye, it rests comfortably on the face, and it is 3D stereoscopic. Laser light is safe for prolonged use. Like any light source, it simply needs to be applied correctly. Our technology can serve all mobile display platforms. The addition of pass-through video allows for mixed reality. To understand why our technology is so radically different from other eyewear, we need to take a closer look at the optics. Our paradigm depends on the ability to take the light output of a laser projector and squeeze it through the pupil of the eye onto the retina. This is not a trivial task. It has been an obstacle to the use of this technology despite laser light's inherent advantages: high energy efficiency, deep color saturation, and extreme luminescence. AV has developed the technology needed to overcome the two critical problems: a small field of view and a small exit pupil. Let me explain. Some manufacturers using laser light projection rely on a type of optics called a combiner or birdbath configuration. By reflecting the light on a curved surface, it allows the display to be superimposed on the real-world view with good resolution and a wide field of view. This optical solution is particularly prominent in the aerospace applications, but the large size and poor ergonomics for mobile display are obvious. Consequently, nearly all products today use a waveguide solution. Waveguides are complicated, but simply put, they propagate light via total internal reflection and then periodically let the light escape across a wide viewing area. But waveguide physics degrade the resolution of the light source, and their materials obscure the real-world view. Most are neither compact nor appropriate for everyday mobility. In see-through augmented reality, the digital display itself distracts from the subject of the viewer's concern. In these two images, we see an anesthesiologist looking out over the surgical field and an EMT leaning over a patient. In both cases, the subject of interest is obscured. Contact lenses for augmented reality have been in development for over a decade, with or without accompanying eyewear. Contact lenslets greatly enhance image quality when coupled with head-mounted display. Standalone contact lenses are complex, requiring an extremely small light source and internal optics to guide the light path. Design limitations include reduced central resolution, field of view, and light efficiency. The earliest companies to try this approach met market resistance to placing a lens on the eye. Content fixed to the eye may be distracting and obscure the real-world view. However, contact lenses represent the ultimate in ergonomics and aesthetics and may be the best form factor for some applications. AV needed to work through these same problems. The earliest AV design shown here resulted in a proof of concept demonstrating the feasibility of virtual retinal display. However, traditional refractive optics were insufficient for the product performance we envisioned. These optics work well to achieve a small 15 to 20 degree field of view, but beyond this the quality rapidly deteriorates, particularly at the margins. At Amalgamated Vision, we found the solution in a pancake lens, allowing us to fold the light path into a compact space. Our smallest optical proof of concept, shown here, fits comfortably on the face, beneath the eye, and out of the way of the user's primary visual field. It produces a 45 by 12.5 degree field of view, the equivalent of two smartphones held horizontally side by side about 15 inches from the face, more than adequate for understanding digital text, graphics, or video. AV technology is flexible. We can scale larger if necessary. For virtual reality applications, where complete occlusion of the real-world scene is acceptable, we can achieve an 85 by 45 degree field of view. Many people think a larger field of view provides a better user experience, but for most tasks, people really only use their high acuity central vision, represented in this slide by the yellow circle. This occupies the central 20 degrees of the entire 200 degree by 135 degree field of view. The magnified drawing gives a better perspective. We see the high acuity central region and the AV display below, inconspicuous in the peripheral field. When the person looks down, the display comes into view. AV optical engine performance is superb. The spot diagram and distortion field shown here is too technical for most viewers, but it is instantly understood by optical engineers. Resolution meets the limits of human vision, and it is excellent across the entire field, an unusual achievement for laser display. Chromatic aberration, a rainbow-like distortion of light, is nearly absent. Because our system is on axis, there is no field distortion. Earlier, I spoke of two critical problems. We discussed how AV solved the first one, a small field of view. Now let's discuss the second, a small eye box. Also known as an exit pupil, it is the zone where the eye is able to see the image. A larger eye box allows the eye to wander. What makes our design truly unique is an eye box of 8 millimeters, considerably larger than the typical laser projection of 1 to 2 millimeters, and it rivals any waveguide technology. This engineering tour de force solved a problem that many considered to be the unsurmountable obstacle in laser eyewear design. Pancake lens optics and laser beam scanning have been available for decades, but Amalgamated Vision owns the IP the rest of the industry is headed towards, the combination of a relay pancake lens with laser beam scanning in an ultra near to eye position. Furthermore, the fabrication methods and laser beam scanning products needed to build our light engine have been in use for a generation and are readily available and dependable. The use cases for this technology are endless. There is immediate applicability to the aerospace industry. The NASA Artemis project, Boots on the Moon in 2024, is looking for technologies that can satisfy their need for hands-free, high-quality informatics display. Our technology, small enough to easily fit inside the helmet of an astronaut or a pilot, offers a solution for just-in-time information that keeps the wearer connected to their environment. In theory, AV optical technology will function under extreme conditions and without gravity. It is light, moves precisely with the head, and it does not touch the eye. Closer to Earth, engineers, mechanics, and support personnel can benefit from hands-free data that does not obscure their vision, allowing them to work efficiently while retaining situational awareness. Corrective lenses or safety glass can be easily attached to the superior surface of the eyewear frame. The aerospace industry is just one potential customer. Healthcare needs a high-quality and inexpensive method to deliver hands-free data. Obscuring the vision of healthcare providers is simply not an option. Surgeons, interventionalists, nurses, emergency technicians all need to move freely, work with their hands, and reference patient data, whether it is medical imaging, vital signs, or patient history. Stereoscopic 3D information enhances the understanding of complex anatomy. Telemedicine for either expert guidance or patient contact is rapidly becoming routine practice in global healthcare. In addition, our eyewear can be easily adapted to assist visually impaired people thanks to the unique properties of laser light, intense luminescence, narrow beam, and always in focus. In just 8 months, COVID changed the habits of the entire planet. Portable digital information will continue to become more essential as people adopt new remote work practices and a more mobile lifestyle. For spatial computing to become truly mainstream for both consumers and enterprise, it is necessary to have eyewear that everyone will embrace and enjoy. The largest companies in the communications and information industries are betting their future on 5G and increasing use of digital data. There are currently 3.5 billion smartphones in the world. Every one of them represents a potential customer. The potential sales within the combined extended reality market is huge. Analysts estimating gross revenues to reach $42 to $56 billion within 5 years. The go-to market strategy is simple: AV Inside. Selling light engines to power other manufacturers' head-mounted display, an OEM arrangement, or licensing our core technology are the most likely scenarios. The first target industries are price-tolerant, data-driven, and display-dependent: aerospace, defense, healthcare, enterprise. As manufacturing costs decrease, the AV light engine will power the eyewear that supplements or replaces the consumer cell phone. At this time, I would like to introduce our team. Dave Kessler, a Kodak Distinguished Scientist, is globally recognized as one of the foremost optical engineers for head-mounted display. Alex Tokman, the former CEO of Microvision, a publicly traded laser MEMS company, is an Allen Institute Fellow. Randy Sprague was the former chief engineer at Microvision and the former CTO of Innovator, an augmented reality contact lens company. I am a former associate professor of radiology and director of the 3D imaging lab at NYU Langone Medical Center. I currently lead product development for Olea Medical, a medical imaging software company. All AV personnel have experience in the world's leading technology companies. Our proof of concept, the light engine shown to you today, is project ready and can be built within 9 months. To date, we have raised $326,000 US. We are seeking $2.2 million to take us through the next phase before building a commercial prototype. Our non-obstructive, look-down, laser-based virtual retinal display is radically different from all other technologies on the market today. It has the potential to make everyday spatial computing a reality. The cultural and financial impact will be unprecedented. Amalgamated Vision is the catalyst that can make this happen right now. And if it is not yet readily apparent, it is our dream at Amalgamated Vision to put our eyewear on a NASA astronaut. Thank you very much.
But anyway, so the final decision, we selected 3 companies. Amalgamated Vision. So it's a virtual retina display. It has potential applications for NASA, particularly using it in spacesuits for displaying things that are of interest to us. Could potentially lighten spacesuits because we don't need as many display, particularly on curved structures.